Dear students, welcome back to Real Physics, Real Life Physics. This is Satya. Let's start this video with some beautiful real life situations. Suppose you went to the vegetable market and you want to buy tomatoes. How do you buy them? How do you ask? You will ask the seller, give me 1 kg tomatoes or 2 kg tomatoes, right? Or if you want to buy milk, then you will ask the shopkeeper, give me half liter milk or 1 liter milk packet, right? And suppose you want to order a shirt or a dress online or you want to buy it from the nearby showrooms. Then how do you order it or buy it? You have to mention the size specifications like medium size, L, XL, etc. Then only you will be able to order the dress that suits your size, right? These L, XL, etc. are letter specifications, but their number specifications are 42 centimeters, 43 centimeters, like that. And similarly, suppose you want to go to a place so that you want to book a cab. Then what do you look for? First thing you look for is how far is that place from your location, like how many kilometers, and how much time it will take to reach that place, like 30 minutes, 40 minutes or 1 hour, 2 hours, etc. And then you will check for how much it costs, like how many rupees or dollars, etc. These kgs, liters, centimeters, kilometers, minutes, hours, rupees, dollars, all these are called units, which are used to measure the physical quantities like vegetables, dresses, money, time, distance between two places, etc. Without these units and measurements, we cannot communicate with the world around us and we cannot make informed decisions. So, units and measurements are the most important part of our lives. These are fundamental to understanding and interacting with the world around us. They form the language through which we quantify and describe the things. In real life, everything from cooking to construction, technology, and even our daily activities relies on accurate units and measurements. Wherever you go in this world, you can use the same units to represent the same physical quantities. That's why these are standardized units. Among all the physical quantities, length, mass and time are the foundational quantities in understanding and measuring the physical world. If you represent these three quantities in terms of units like centimeters, grams and seconds, that is called CGS unit. Means centimeters, grams and seconds system of unit. And if you represent these three quantities in terms of units like meters, kilograms and seconds, that is called MKS unit. Means meters, kilograms and seconds system of unit. This MKS unit is a part of International System of Units, which is simply represented as SI units. The SI system is the modern, internationally accepted system of units used globally across scientific, engineering and commercial disciplines. It has expanded beyond the MKS system to include additional base units for other physical quantities such as the electric current, measures in terms of units called amperes, and temperature, measures in terms of units called Kelvin. Of course, Kelvin is used in scientific context, but we often use Celsius or Fahrenheit for everyday measurements. And the next quantity, amount of substance, measures in mole, and luminous intensity, measures in candela. Now, just imagine you are in a car. You measure how fast you are going in meters per second or kilometers per hour, right? That means how much distance your car is traveling in how much time. For instance, if your car is moving at 20 meters per second, this means it travels 20 meters every second. So, we measure the speed or velocity of the car in terms of meters per second, that is distance by time. And if you press the accelerator pedal, as the car starts moving faster, its velocity increases over time. The car is gaining speed at a certain rate, which is its acceleration. Means the rate at which the car speeds up is its acceleration. If the car's speed increases by 10 km per hour every second, it is accelerating at that rate. And when you play a football, you have to kick that soccer ball. Means you have to apply some force on that ball by using your foot. How much force you have to apply is based on the mass of that ball, means weight, and acceleration of that ball. That means if the ball mass is high and it has to go faster to reach the goal, then you have to apply a high amount of force. So, force equal to mass into acceleration. So here we are measuring velocity in terms of meters per second and force in terms of newtons, that is kg meter per second square. That means we are using the combination of units to represent the quantities like velocity, force, etc. These are called derived units. That means derived units are a combination of base units. So, units and measurements allow us to quantify and compare the physical world in a way that is understandable, organized, and useful. They give us the precision to make informed decisions in everything we do, whether it's cooking, traveling, or building. Without a system of measurement, the world would be chaotic and disconnected, making it impossible to perform the activities that shape our daily lives and progress as a society. Stay connected. See you in the next session.